Hello, everybody. Welcome to Revere Electric's webinar on grounding and bonding basics of VFD cable. During the event, you can use the left pane to navigate between chat and other event information. Please submit questions live through the chat window where the moderator will respond or bring them to the attention of the presenter. There'll also be some poll questions that will show up in that area as well throughout the presentation. Feel free to answer those as you're listening. For those that want the presentation display larger, there is a full screen option. Again, today's topic is grounding and bonding basics of VFD cable, and the presenter is Josh Kuhn-Kramer and Will Darrow. Josh is the regional sales manager at LUTZE. He brings a wealth of experience in factory automation and applications of VFD cables. Will is the senior product specialist at LUTZE, working for several years in this field supporting customer applications. They will be providing an overview of the grounding and bonding of VFD cables. With that, we'll turn it over to Josh and Will.
Thanks, Jim. And thanks everybody for showing up to the webinar today, or viewing after the fact. As Jim mentioned, today we are going to be going over a couple topics regarding VFD cable and grounding and bonding. We will assume that attendees have a decent level of understanding of VFDs and motors, but feel free to raise your hand or add a question to the chat window, and we can cover additional topics as needed. We'd like to cover a few topics, as noted, surrounding VFDs. We'll touch on some components of a VFD system, VFD-specific cable, as well as how and where to ground that cable. We'll also cover a few good documents that are linked to this webinar that might be of good use after we're done. Diving in, again, hopefully everyone here knows a little something about VFD. I'll say my personal definition of a VFD system is everything between the VFD and the shaft of the motor. In the past, I would have said it only included the VFD, the motor, and maybe the cable to connect them. But there are other components that are used to help deal with the electrical magic that a VFD creates. As you can see on this chart, there are a handful of issues that a VFD creates. Voltage overshoots, reflected wave, electrical noise, excessive wear on motor components, and of course VFD faults. These different issues have different levels of severity based on some factors and different tools or components that can be used to alleviate the pains from these issues. And those are the things you see across the top there. VFD cable, line and load reactors, filters, ceramic bearings, and shaft grounding rings. But it's important to know that none of these solutions is a silver bullet. None of these checks every box in every situation, which is kind of why we like this chart. It's good to think of the healthier VFD in a kind of holistic way. Today we'll be focusing on the VFD cables and how to best implement them into your VFD system. Okay, we are going to pop up some poll questions throughout the presentation here, but I'll make this one a little more interactive. Does everyone here use? Oh, sorry, Jim,
pop up the one poll question around VFD cables, and everybody attending said yes, they are familiar with VFD cables.
All right, all right. So why do we use VFD cable? The first thing I would say is because your motor likes VFD cable. As we said earlier, VFD cable is good for the motor's shaft bearings, but it also helps with reflected wave and high voltage spikes. While some of these issues can cause immediate faults or visible issues, some of these can be longer term problems with impact seen later in the life of the system. Next, your drive likes VFD cable because the specific use of insulations found in VFD cables prevent catastrophic cable failure after continued exposure to overvoltage spikes and electronic magic the drive creates. This cable also makes the drive more efficient. So NFPA used to say, and I'm quoting it verbatim from the 2018 standard, that electrical conductors and equipment supplied by power conversion equipment as part of an adjustable speed drive system and servo drive systems shall be listed flexible motor supply cable marked RHH, RHW, RHW2, XHH, XHHW, or XHHW2. And these are specifically intended to call out insulations around those conductors that can't handle voltages created by the drive. This has since been kind of softened by the NFPA, but it still serves as a good guidance towards best practices. And maybe I'm just doing it because all my friends are doing it. This is kind of a joke, but VFD cable really is an industry accepted solution. You wouldn't hook up your TV with an RCA cable anymore. You'd use an HDMI, right? Well, this is the same thing. It's an application-specific product. And while we're discussing VFD-specific cable, we'll tell you that not only are we this webinar's presenters, LUTZE also makes some really good VFD cable. Our cable is specifically made to handle the unique electrical characteristics that a variable frequency drive creates, but it goes above and beyond typical VFD cable. We use a highly stranded conductor in our construction that makes the cable very easy to route and work with. The rest of the construction, including the insulation, the shielding, the tape, all works together to create its own system that's lower in capacitance. This means the drive charges the motor faster with less charging current than poorly insulated options. That means the drive and the motor work more efficiently. As you'll see in the following videos and slides, the cable's construction also makes it easier to strip, easier to ground, and easier to handle.
Josh, second question we asked was, have you ever experienced cable failure with VFD system? It was kind of interesting. We have a split, kind of a 50-50 split on the answers between yes and no on that.
Okay, that'll be interesting to follow up on. Thanks, Jim. So here we get to the somewhat interactive portion of the webinar. We're going to start the process of stripping the cable by making sure the depth of the blade matches the depth of the cable jacket. You can see me holding the stripper here. Then you'll see I make a ring around the cable. And no movie magic here, as you'll see I don't actually get a complete ring around the cable. That causes a little piece of cable to remain connected and give me a little hassle with removing the jacket. We'll leave this poor performance in the discussion because at the end of the video it shows, there it is, it shows what makes this cable easy to work with. Instead of letting the jacket melt into the shielding braid, we'll add a layer of fabric between the jacket and the braid. And you'll see that this allows for easy stripping, but it's also a contributing factor to our great flexibility. And here's another oops. Oops, this is actually the strip that was intended to be the start of the window strip, but it was done in reverse order. I just wanted to show this to note that the jacket starts sliding off before we can even make a horizontal cut. That's how easy the cable is typically to strip. This is kind of an interactive question or quiz. You know, which end of the drive cable should be grounded? Is it the motor end, the drive end, both ends, or neither ends? And if you guys have any sort of familiarity with this, you probably know the answer is both ends, and that's going to be where our discussion goes next. To the motor end. And I refer to this as kind of a system at the motor end because it's the result of specific components working together for an end result. And we'll start with that window strip. We'll make 2 rings cut into the cable and then a horizontal, or you could do a spiral cut to connect them. Again, you'll see that the fabric around the shield is going to pay some dividends in making this a pretty simple process. Again, this is called a window strip. And here's a look at that EMC fitting that was referenced in an earlier slide. And the process you'd use to connect this at an actual motor junction box. This diagram is in one of the documents we'll attach to the webinar's page, as well as the catalogs page on these fittings. And here's the simple process of installing it. The shape of the teeth inside the fitting allow it to slide over the cable's jacket from either direction and then get tightened like a traditional fitting or cord grip. This is going to provide us with a NEMA 4X seal, strain relief on the cable, and is a great solution at the motor side of a VFD system. On the other side, again, we're grounding both sides of our cable, the VFD and the motor. On the other side, within the VFD or in the cabinet containing multiple VFDs, we have a little more room to work and a couple other options for grounding. The less popular of methods is an EMC rail and clamps. It's another system, so it's some specific components designed to work together. There's a specific rail, some clamps to physically secure the cable in place, as you can see on the upper right and the lower center. Some size-specific grounding clamps, and that's shown in the lower left, as well as a kind of versatile spring grounding clamp shown in the lower right. So that can actually accommodate multiple sizes of cable. Again, these aren't the most common or popular option, but they're good to know about and might be a good fit in certain designs. We do see these come up in, again, cabinets where there's multiple drives kind of terminated in the same spot, cabinets where cables are fed in from the bottom. And I've seen this a bunch in robotics cabinets. It seems to be kind of popular. The more popular or common method is the pigtail method. And this method involves turning that braid and drain wire into an extra conductor, as you'll see in the videos that follow. Of course, we got to start the process for the pigtail with a basic strip. The next step is folding back the braid to access the foil shield underneath. So our cables utilize two shields as a method of noise reduction and, you guessed it, flexibility. Inside of that VFD, we'll just use the braid. So again, we're going to trim back the foil shield that's inside the braid. Since this is all so exciting, this is the most mundane step in the process, where we remove some excess filler material that's placed between the conductors, which helps us keep the cable round. This is a great time to mention that these steps are a lot easier on a bench or a table. So big thanks to product specialist Will Durrell for being a steady hand for these demonstrations. And I will toss in another plug. Those fillers, like I mentioned, help keep the cable round, and that helps the fit with the fitting a lot better, or any sort of gland plate or entrance into a cabinet. That really helps maintain appropriate environmental ratings, having a round cable. Next thing we do, we'll fold that braid back up over the conductors, and we'll open a window through which we can bring the conductors out. With that open window, we've pulled out one conductor, and Will's going to show us the process of pulling out another. And again, this is much easier when you've got, especially when you've got 100+ feet of cable behind you, because that actually kind of acts like a nice anchor that you can leverage against. But Will's a pro, so he's handling it well. There we are. Now we'll watch it 2 more times. Just kidding. Here we see the separated conductors as well as that braided shield. You'll notice that braided shield is now empty, except for that drain wire is now inside of it. Again, we'll remove the conductors. Now that braided shield just has the drain wire inside. And now we'll clean up that new conductor. We'll pull the braid tight. We'll trim the end so it can fit into a terminal and wrap it with some heat shrink or more likely some electrical tape. We won't show you how a screwdriver works, but note that the drive has 2 grounding terminals ready to receive the ground conductor, as well as that new conductor that we've created from the pigtail. Next, we're going to move on to kind of an interesting question within the grounding discussion, and that's, what if there's a disconnect in the system? And well, I found a nice graphic of one of those fancy new Hubble disconnects that features, it's like a cross between a disconnect and a grace port. It's got some indication lights to confirm that off is off, and might sound kind of hokey, but I'll never knock something designed to keep people safe. And now we'll briefly touch on how to wire this unit up when using VFD cable. And I'll toss it over to Will.
Thank you, Josh. So when terminating our shields, there's a couple of rules of thumb you want to follow. First off, when we're dealing with power cables, we want to terminate that shield on both sides of the cable, so at the drive and the motor. Versus when we're doing a communication pair or a communication cable, the rule of thumb is typically to only terminate that shield at the source. And the reason for that is with power cables, the shield provides another great path for any noise generated on your motor junction box or motor frame to drain back to your VFD, back to the source where it wants to go. Whereas with communications, you want to try to prevent cables, you want to try to prevent ground loops. Now, when you throw a disconnect in the middle there, you introduce this separation that breaks apart your cable into 2 parts. And there's a few different ways you can make that continuous run through from the VFD to the cable or to the motor. And one of those is to use EMC fittings on the junction box, provided it's a metal junction box that won't do anything if it's a plastic or other kind of polymer. But the risk there is that because you're using that box frame to link your shield, your noise can go onto the frame, find a path on your ground system, and then create havoc somewhere else in the system before it ends up draining into the source. So while this is a feasible option, it is not highly recommended. A better solution would be to possibly use ground backplate found inside your box, your disconnect. However, this can also run into similar situations, a little less likely, but since it is also connected to your ground network, you could have issues as well. Possibly another solution, still better practice, is another grounding terminal, like you would do with landing your shield at your VFD side. This is a great solution. It gives it a good place to land and helps prevent some of that possibility of noise getting out as well. But possibly the best solution, and the last one we'll show, is using an isolated terminal block to maintain that continuity of your shield. So there isn't an area where that shield can have that noise find a lower resistant path through your ground network and create havoc elsewhere. the key to your shield continuity is making sure that that shield, as a tool for bringing noise back to your start, is that you don't want it to have a easier path for that noise to travel elsewhere. So it wants to be the path of least resistance for your noise to travel back to the drive. And that's another reason why when we show the pigtail method, we're keeping a lot of that braid shield along with the drain wire. Because if you just use a drain wire, sometimes that's not enough copper, and you create a higher path of resistance through that drain wire than the noise can find elsewhere, and that can lead to havoc. So rule of thumb is to always use as much copper as possible, and that's why we throw in that braid shield as well when we're making our pigtails.
Thanks, Will. And this is actually a picture from the Revere Training Center. And can you guys see the terminals here? We'll zoom in. As you can see, the disconnects can be ordered with some extra terminals to help pass along that extra pigtail that Will was talking about. And this is, as you can see here, there's a bunch of different configurations you can add. So if you have signal pairs like Will was talking about, or other circuits that are integrated in with your VFD system, you can order your disconnects as such. For more information on this, you'll want to consult your favorite disconnect manufacturer and make sure your options are optimized. And quick shout out here of thanks to the local Hubble team for providing a bunch of information for us for this webinar. So thanks, Ed Becker and his team. As noted earlier, there are going to be some technical documents housed here in the webinar, so please take a minute to see what's there. One of those is Alan Bradley's own wiring and grounding guidelines for drives. There's a lot of good information in there. And they'll even note that, and this is taken right out of the book, because drives create voltages in excess of line voltage, the industry standard cables that were used in the past are not appropriate for variable speed drives. Drive installations benefit from cable that is different than cable used to wire contacts and push buttons.
Josh, before you go to the next, we did have a question come in. Is this okay time to ask a question?
Absolutely.
So question from the viewer. If the motor is disconnected, there is no motor current. Where is the noise from for the shield?
Yeah, I can take a shot at that one. Yeah, so when the motor is disconnected, it's obviously not running, and then you're not creating any noise from your motor. It's more important when it is connected, and you're making that noise. The question we get from a lot of customers is that what to do with that shield when they're passing through that disconnect, because it is a section of your installation where you're basically cutting the cable in two. And we've often got the question of how do I reconnect these components back together, especially the shield, because as people are moving more and more to VFD cable, we have a lot of customers who are switching from unshielded power cable or even THHN, and they're not familiar with best practices for terminating that shield and keeping that continuity. So those are just several ways that you can install your cable at a disconnect in order to maintain continuity and keep your effective shield of being terminated at both the motor and the drive.
Another question came in, a slightly different topic, but this one reads, many drives, including Rockwell PowerFlex series, have ground studs which need to accept ring lugs. Can we really terminate the shield pigtail inside a ring lug?
Yeah. I don't see, I mean, we're essentially, as we showed in that cleanup slide, we're kind of twisting it into its own new conductor. So you may have to do a little experimenting to find the appropriate size of the ring lug, but yeah, we're essentially making it a conductor.
Yeah, to add on to that as well, when you do make that pigtail, at first the ends of the braid can get a little frayed and can kind of spread out like a frayed rope almost. To kind of get around that, you can actually trim a little bit off the edge, and you get a pretty consistent conductor as well, where you would be able to put that ring lug onto.
And then I had one final question. This one actually came in around capacitance. And I know in preparation for this, we talked a little bit about the value of the reduced capacitance, low capacitance in the cable and how that benefits the VFD, but maybe you can speak to that relative to, if you want to relate it directly to LUTZE cables, you can, but it's really addressing why is it important to have cables that have low capacitance, and is in particular on VFD applications.
Yeah, I can take that. So capacitance is basically the cable. When you first turn on the power, it's going to act like a capacitor, which in simple terms is kind of like a battery. It needs to be charged up before it acts as a conductor. So with any cable you're using, you have this, what we like to call charging current, which is the amount of electricity you need to put into that cable before your motor is going to see anything. And the higher the capacitance of the cable, the more electricity you have to go into. And so that can cause excessive charging currents on startup, which can lead to nuisance tripping. Basically, you require so much current inrush at the beginning of startup that you could trigger an overcurrent fault on your drive, just due to the amount of copper that needs to be energized before you get the motor to go. This is also a factor that leads into efficiency, and so the higher capacitance, the less efficient it goes, but it also puts more stress on your drive as well, because you've got a more current draw coming out, and it can also limit your run. With our cables, we use a very low capacitance insulation, which helps mitigate some of those issues on the current side, and keeps you running very efficient. That's one of the main reasons you run a VFD in the first place, is efficiency. You can squeeze out some more efficiency with a low capacitance insulation as well.
Thanks, Bill. That's all for questions for right now.
Thanks. I just kind of thought I'd jump to the local contacts there so you can see who Will is and again what he does. Some other things that we did attach to this are some LUTZE specific documents. A couple of them are more instructional white papers. You'll actually find the instructions for creating that pigtail, and another document regarding the disconnect, as well as our digital catalog and a little extra informative page on those EMC fittings. So again, EMC, electromagnetic compatibility. That's our grounding fitting, especially useful at that motor end. And back to this slide, you'll find your local contacts if you have any technical questions on drives or the products or techniques seen here. And again, you can reach out to your Revere account manager. And we always try to remember to consider the entire system you're working on with VFDs. It's never just a motor and a drive, is it? So that's what we got, Jim, if you want to clean it up.
Thank you. Yeah, I will, and we'll monitor. I have a few closing thoughts. I did, thank you, Josh and Will. I'll check the chat window as I'm kind of doing some of these closing comments, but that was a good conversation, and I do appreciate the folks attending, presenting questions. If other questions come up, feel free to email us up at Revere. So, but I don't see any other questions coming in. So, thanks again, Josh and Will, for your time. For those of you watching, if you, again, have further questions, reach out to your Revere Electric account manager. One request we have is once we sign off, we ask that you please take a minute to complete a survey at the end. The feedback that you provide us helps us to continue to deliver informative content on the most significant technologies and solutions and challenges that you're seeing. So we did have one more question come in, Josh, if you've got a minute.
Absolutely.
Okay. So one question that did come in, it makes sense, and I'll just read it. I'll read it verbatim here. It makes sense that the VFD cable insulation is typically XLPE or another thermosetting material due to the low dielectric constant. However, almost every VFD cable manufacturer uses a PVC jacket. Why is this? In the power generation industry, most manufacturers do not allow any PVC materials, so this poses a significant problem.
Yeah, I can tackle that.
Okay.
In our major space, which is industrial automation cables, PVC is a widely accepted norm for not only insulation, but jackets. It's easy to work with. It's very cost effective and provides good results for those reasons, especially at lower voltages. We switched to XLPE on stuff like VFDs due to a lot of spiking on the insulation. But due to still relatively low voltages, we're talking about not much more than 1,000 volts typically on the spikes. In worst case scenarios, you get up to like 1,500 volts, but the XLP helps to keep that down as well. Where the jacketing material doesn't matter so much electrically as it does matter for your physical properties of your application, such as any kind of chemical exposure, oil exposure is a big one, sunlight and such like that, where a PVC with the right additives and compounding does very well in a industrial automation environment. So your typical factory, stuff like that. Our PVC does have a lot of those additives where it's resistant to a lot of those sunlight, where oil resistant, as well as several different types of chemicals. But because it doesn't play so much an electrical portion of the cable in this situation, it's still allowable. Where we see other cables come out like TPE and PUR, those kind of jacket materials are typically for more specialized applications. PUR is very common in high flexing applications due to it being very abrasion resistant. Same with some TPEs. Or heck, you can even further stretch out your oil resistance. You can put other additives in there that make them very robust and flexible for at very low temperatures and stuff like that. So from our perspective of when we're making cables, electrically, we're looking at the inner conductors, and the outer jacket is more so for the physical application, if that makes sense. I hope that answered your question.
Is there an alternative to PVC in an industry like power generation as a jacket material? And maybe this is a question to take offline with this particular customer, but
that's fine, Jim. I think you just get into a different class of cable, right? You get into that medium voltage, higher voltage product, right, Will? And we're just talking about kind of that generic industrial application. And I use generic in a good sense. I mean, this is where Revere plays, where your customers are located, just getting into that highly specialized cable that's going right to We Energies or MG&E is that gets into a different class. We do have this is a great
Josh, 1 second. So that the customer, the attendee replied back, power typically requests CPE.
Yep.
Okay.
CP is a very common jacket material used in, process automation sort of applications.
Okay.
At this time, we do not have a CP option.
Gotcha.
That's standard, but it is something that we have been looking at for the future.
Okay.
Yeah, just a real quick plug here, Jim. So the cables we've been referring to here today are our standard DRIVEFLEX classic cables. We do have some more robust jacketed versions that are more chemical resistant in our FBP cable line, which is more focused on the food and beverage processing environment. And then we've got some drive specific cables that are now motion capable. So they're able to be used in some torsional flexing and linear track applications as well. So we are coming out with new things, for new applications as we see it.
Okay. Thank you. And thank you for that question. With that, there are no further questions. So again, there's a survey at the end. It really does help if there's topics that you would like to see us put on. We sure are open to the ideas. But again, once again, thank you for attending, and make sure to visit Revere Electric's Virtual Education Center for additional webinars.